2.5 is on vectors, and we are going to be using a geometric approach to vectors. Our objective for today is to use vectors to calculate distance by finding the true course. A vector is going to be an object that has both a direction and a magnitude. This is a drawing of what a vector would look like. It's going to be an arrowhead, and you'll notice it has a tail where it starts and then the head of where it ends. The magnitude is going to be the length, and usually the magnitude is given with a speed or a velocity. This table shows a few different notations. Most commonly, you'll see the vector named with 2 points that are on the vector or just with a V. And then if it has these absolute symbols around it, that is going to be the magnitude of the vector, or how long it is. Two vectors are going to be equivalent if they have the same direction and the same magnitude. So if you look at these examples, V1 and V2 are going the same direction and are the same length, which means they have the same magnitude. If they're the same length with the same magnitude, but are going opposite directions, then these are called opposite vectors. So 3 and 4 are an example of opposite vectors. When we add two vectors together, for example, if we take vector u plus vector v, we are going to start by drawing what vector u looks like, and then we are going to add vector v to the end of that. Then we are going to draw a new vector from our starting point to the end of our second point. This new vector is our answer for vector u plus vector v. Method 2 shows another way that we could find this, but the first method that we went over is going to be the one that we are going to be using in our examples and in our homework. When we're subtracting vectors, we use basically the same method where we start with the vector u, and then if we're subtracting vector v, we just draw it going the opposite direction, and that is what u minus vector v would be. And again, we start at our starting point with our new vector and then go towards the end of our second vector to get our results. A little bit last of information, we are going to be doing navigation, which is the angle between the north-south line and the vector representing the path. We're going to go over some examples. For this one, the navigation would be over here, and that would be the angle between the north-south line and the vector representing our path. The heading is going to give us the direction of the object traveling, like a plane or a boat. And that's also going to be giving us an angle between the north-south line that the vector is going to be representing. Then we have our true course. This is the direction that the object takes because of other factors like winds or currents. So when you're flying a plane, you could be flying directly east, but if there's a north wind, your path would be a little bit off. Or if you're sailing a boat and you are sailing directly north, but there's a current that's going south or a current that's going west, it would push you a little bit off course. So you always want to pay attention to that when you are traveling with that method. And next we have bearings, and this is measured from the north or the south line going east or west. And that is what we went over in section 7.4, day 2. Now we have all of the information that we're going to use, and we're going to do some examples. Example 1. For this one, we have a boat is crossing a river that runs due north. The boat, this one has a typo here, is pointed due east and is moving through the water at 12 miles per hour. So we know the boat is going east and is going 12 miles per hour. So we're going to draw a vector that represents the boat. And we know the direction is east. The magnitude is 12 miles per hour. And that is how we are going to start that problem. Next, it says the current of the river is a constant 5.1 miles per hour. And the river, we already were told, runs due north. So at the end of our first vector, we're going to draw our second vector going due north. And this one was only 5.1 miles per hour. And we know it was going directly north. They want us to find the true course of the boat through the water. So from our starting point, we know there's a direct north there, and that would form a right angle. We need to figure out what the angle on top would be. We also need to figure out the length of this vector. So using our right triangle here, we can figure out all of that information. To find the magnitude, we can just use Pythagorean theorem, where we take 5.1 squared plus 12 squared, and that will give us what x squared equals. Grab a calculator. Okay, so we have 5.1 squared plus 12 squared. That would be 170.01. And then we're going to take the square root of that value, which is about 13. And this is going to be miles per hour. So that tells us how fast the boat is actually going when you include the current of the river. Next, we need to find the angle. Before we can figure out that angle, we're going to find this angle inside of our right triangle. So using tangent, or inverse tangent, of 5.1 over 12, we can figure out what y equals. So typing that into our calculator, we would have 5.1 divided by 12, and that equals about 23 degrees. And we can round to a whole number because that's what it said to do in our directions. But we need to make sure that's not where we stop because we weren't actually looking for angle y in our final answer. We need to figure out what theta is. And theta is going to be equal to 90 minus that 23 degrees because we're only looking for that top portion of that angle. So when we take 90 minus 23, we're going to get 63 degrees. And we need to state what direction that 63 degrees is going. So we started from the north line. So this is going to go north 63 degrees. And then we were going towards the east direction. So that would be our true course of our boat. Our next example is pretty similar to this, except this time we're talking about a plane. For this, we have a plane that is flying 170 miles per hour with a heading of 52.5. When we're working with headings, we're always going to start from our north vector. So we have a plane that's going 170 miles per hour at 52.5 degrees. And that 52.5 degrees always is the angle from the north line because we are working with headings. So we have 52.5 degrees. And we know this is 170. At the end of that vector, we're going to draw a second north vector because no matter where we are, north is always going the same direction. And then next it says the wind currents are a constant 35 miles per hour at 42.5 from due north. So I'm going to add that over here. We know that this angle up here is 142.5 degrees. And we know that this is 35. They want us to find the ground speed, which is going to be the magnitude of our resulting vector here. And then they also want us to find the true course of the plane, which would be the angle from the north to our new vector. Now that we have our picture, we need to figure out if we have a right triangle, and if we do, where the right angle will be. So this is going to bring us back to a little bit of geometry. And we have these two north vectors here, which are parallel to each other. And if you look, we have same side interior angles for the angles that I highlighted. Those two angles are going to be supplementary to each other. So because we know one is 52.5, we're going to take 180 and we're going to subtract that. 180 minus 52.5. So we know that the angle next to it is going to be 127.5. Now the reason that I found that angle is so that we can now find the angle that's inside this triangle corner here. Because we know two of the angles here, we can figure out the third one because all together, they all are going to be 360 degrees. So I'm going to add 142.5 to the 127.5. And we are going to get 270 degrees. So to find that missing angle, we're going to take 360 minus 270. And you probably already know this answer, but that is going to be 90 degrees, which means we do have a right triangle with that being our right angle. Because we're only working with right triangles, all of these problems are going to form a right triangle somehow. So you just have to figure out where it is in our diagrams. Now that we have that information, we can go ahead and solve for what we need to know. So first, we're going to look for the magnitude. So I'm going to take 170 squared plus 35 squared. And that's going to tell me what x squared equals. So we're going to get 30,125 equals x squared. Take the square root of that, and we'll get about 173.6. And this one is still miles per hour. And that is equal to x. Next, we need to figure out the angle that our new vector is taking. So our angle, you'll notice, is going past the original angle we were given with our first vector. So we're going to figure out what y equals, and then we are going to add that to the 52.5. So we know that y is going to equal the inverse tangent of the opposite side, 35, over the adjacent side of 170. So again, we'll just type that into our calculator really quick to figure out what that equals. Oh, I'm sorry, I typed that wrong. 170. There we go. So our angle here is going to be about 11.6 degrees. Now to figure out what theta is, we're going to take the original 52.5 degrees and we're going to add that 11.6 degrees to it. So we have 52.5 plus 11.6. So that will give us about 64.1 degrees. And we need to give it in the direction. So we were going from the north of our original north line. Sorry, not that one. We were going from the north, 64.1 degrees, and we were going towards the east direction. If we were going towards the west, then we would put a W, but this one we are going east. So these problems are a little bit longer, but they are worth quite a bit on the test, so it is important that you know how to do them. And the next part that we're going to be talking about is the horizontal and vertical vectors. Basically, what that means is when you have a vector, the horizontal vector is going to be how far horizontally you went left and right. And then the vertical vector is going to be how far up and down you went. And usually you'll see these represented with Vy and Vx. So if you're asked to find the horizontal and vertical vectors, sorry about the dogs, that's what you are going to be asked to do. So here is an example. A human cannonball is shot from a cannon with an initial velocity of 50 miles per hour at an angle of 60 degrees from the horizontal. They want us to find the horizontal and vertical vectors of the velocity vector. So we're going to start again by drawing a picture. That's always how we're going to start these problems. So this one, we're going to just start with a starting point. And the velocity is going at 50 miles per hour. So that's going to be our length. And we know the angle from the horizontal is going to be 60 degrees. And they want us to find the horizontal and the vertical vectors here. So we have our Vx, and you want to think of the horizontal one as kind of the length going along the x-axis. And then we have Vy, which would be the length going along the y-axis. So we're just going to set this up using our trig ratios to find the missing values. So if we start by looking for Vx, we know the hypotenuse and Vx is the adjacent. So we're going to do the cosine of 60 degrees equals Vx over 50. So we're going to multiply both sides by 50 to get the Vx by itself. And then we can type that into our calculators. And this one, we are going to end up with 25 equals Vx. And that's how far horizontal we went. Now we're going to do the same thing for Vy, except this time we're just going to be using sine of 60 equals Vy over 50. Again, we'll multiply both sides by 50 to get Vy by itself. And we could figure out what the exact value of this is, but if you type it in your calculator, that's okay as well, unless it tells you to give exact answers. So this one's going to be about 43.3 for Vy. And that would be our answer there. So make sure you have that copied down before you move on to the next part. Our next part might look familiar for this. We are going to be finding the magnitude of vector, and it can be written in terms of the magnitude of the horizontal and vertical vector. And we are going to be doing this by using the Pythagorean theorem, which we have already been doing in our previous examples when we were finding the missing side of the right triangle. So our first example using this, we have an arrow is shot into the air so that its horizontal velocity is 25 feet per second and its vertical velocity is 15 feet per second. We're going to use that information to find the velocity of the arrow. So we'll start with the beginning. Horizontal velocity of 25 feet per second. So horizontally, that's going to be 25. And then vertically, it was 15 feet per second. So we're going to draw that going up and down. And they want us to find the velocity of the actual arrow. So we're just going to draw that new one, and we're looking for that length. So again, We're just using Pythagorean theorem here to figure out the missing side of a right triangle. So we would have 25 squared plus 15 squared. X squared equals 850. And x would be about equal to 29.2. So the velocity of this arrow would be about 29.2 feet per second. Okay. Our last example for today, we are talking about a boat that travels 72 miles on the course with the direction of 27 degrees. So again, we're going to start with our north vector, and we're going to draw the course of this first ship. And this one's going 72 miles on a course of 27 degrees. So from here, we know this is 72. And we know that angle on the inside is 27 degrees. Then, at this point, the ship is going to change directions. And this one, it changes to travel 37 miles at an angle of 55 degrees. So now, our boat changes directions, and now it is going at an angle of 55 degrees. And we know this length is 37. They want us to find how far north and how far east the boat has traveled on this 109-mile trip. So to do this, I recommend forming two right triangles, one with the first vector, and then one with the second vector. And then we can individually find the Vx values, and then we can find the Vy values, and add them together to find the total horizontal and vertical distance this ship has traveled. So starting with our first one, we know this top angle is 27, so we're going to find the complement to find the angle inside of our triangle, which will be 63 degrees. Now, using that information, we can find the first Vx value by using the cosine of 63 equals Vx over 72. Multiply both sides by 72 times the cosine of 63, and that'll be about 32.7. And that will be our Vx value. Then we can find our Vy value. So this time we'll use sine of 63 degrees equals Vy over 72. Multiply both sides by 72. And that will give us our first Vy value. So that'll be about 64.2. So now we're done with that first triangle. Now we're going to move on to the second one that's a little bit smaller. So we know that top angle is 55. So we're going to find the complement to find the angle inside of that triangle, which is going to be 35 degrees. Now we can set up our problems to find our second Vx value. So we'll do the cosine of 35 degrees, which is going to be equal to Vx over 37. Again, multiply both sides by 37. And then type it into our calculator, cosine of 35. And we will get about 30.3 for this one. Then we can find our second Vy value, and this time we will do sine of 35 equals Vy over 37. The biggest mistake that I see on this problem when we have it on a test is that people mix up which one is the horizontal and which one is the vertical. So you'll want to make sure that you're paying close attention to that when you are solving so that you don't get a point docked off for that. So this one's about 21.2 for our second VY. Now we're going to add them together to figure out our different distances. So our horizontal distance would be 32.7 plus 30.3, which will be about 63. And if you waited till the end, your answer would be a little bit more accurate than this, which is what you probably should do. But I will still accept these answers. So we would have 64.2 plus 21.3. So this one we would have about 85.5. So that would be our horizontal and our vertical vectors. That's the end of this notes for section. Sorry, this one was a little bit longer. If you have any questions on it, please let me know. And here is the homework assignment for tonight. Have a good day.